Hey there, this is MathCamp321, and in this video we're going to talk about the surface areas of circular solids. Let's start with the cylinder. To figure out the lateral area of a cylinder, what I'd like you to think about is the circumference of a circle. So let's focus on this cylinder, which is drawn over here to the right, and I'm just going to highlight the base, which is a circle. Now, if I took that red circle and I stacked more red circles on top of that, you might want to think of a can of soda, maybe a can of Coke, and this would be the red portion of the can. So think of the red portion of the can as a circle, or as many circles stacked one on top of the other. And if we stack a bunch of those together, that's going to give you the red part of the can of Coke. Now, a circle, or the red portion of the circle, can be thought of with the formula 2 pi r. This would be the circumference. The distance around the circle is 2 pi r. But I want to multiply this by the height because there are infinitely many circles taking us from the top to the bottom. So some books call this circumference times height, but I think if you think about it as 2 pi r times h, it might be easier. So that is the lateral area, or the red portion of a Coke can. Now if you want the total area, you're going to want to include the bases as well. So the total area is going to include the bases, and the bases of course are circles, and the area of a circle is pi r squared. So the total area is going to be 2 pi r h, that's the lateral area, plus pi r squared, but there are two of them, one for the top and one for the bottom. So here are the two formulas that you're going to need to find the surface area of a cylinder. The lateral area is 2 pi r h, and the total area is 2 pi r h plus 2 pi r squared. And if you just think about the ideas in this video, then you probably won't even need to memorize the formulas. You can just reason them out. Let's go on to the next circular solid. So the next circular solid we're going to look at is the cone. To find the lateral area of the cone, we're going to use the formula pi rl. Now when I was younger, there used to be a show on MTV called TRL, Total Request Live. This is when viewers could call in and they could, pick a song that they want to hear. TRL. So I think TRL reminds me of pi RL, and it helps me remember the formula. L is at the end, R is in the middle, and the pi kind of looks like a T if you think about the two legs of the pie being really close together. So it kind of looks like a T. So that could help you. TRL, a show that used to be on MTV where people could call in and pick the song they wanted to hear. TRL, pi RL. Awesome. Now, the total area is going to be the lateral area plus the one circular base. So for that reason, the total area is going to be pi rl plus pi r squared. And these are the two formulas for lateral area of a cone and total area of a cone. Let's go on to the next slide. And the last formula that we're going to be looking at today is the area of a sphere. I should say the surface area of a sphere. And there's a little bit of a mistake, or at least a dialogue that has to happen here with the sphere. In the other solids that we looked at, there was either one base when it was a pyramid or a cone, or there were two bases if it was a prism or a cylinder. But a sphere doesn't really have any bases. So rather than distinguish between lateral area and total area, we're just going to think about this overall as surface area, because there's no real lateral area. There are no bases to distinguish. So we're just going to call this SA for surface area, and the formula for surface area of a sphere is going to be 4 pi r squared. And I can't think of any gimmicky way to remember that. You just sort of have to remember that that's what it is. The surface area of a sphere is 4 pi r squared. Let's take a look at some very specific examples now. Okay, so let's take a look at our first example. Number 1. Find the lateral and total area of a cylinder with a diameter of 12 and a height of 13. Well, to me, this problem is just screaming out for a diagram. So I'm going to start by drawing a diagram of a cylinder. Now they tell us that the diameter is 12, and that means or refers to the diameter of one of the bases, either the upper base or the lower base. It doesn't matter. So I'm going to go ahead and label that as 12. Now they also tell us that the height is 13. That would be the distance in between the two bases, so from top to bottom. And let's start with lateral area. And you know that I like to start by writing down the formulas. The formula for the lateral area of a cylinder is 2 pi r, that's the circumference, times the height. So this is going to be 2 pi blank blank. The radius of the circular base, if the diameter is 12, the radius would be 6, and the height is 13. So what we're going to have here is 2 times 6 times 13 times pi. So that's really 12 times 13, or 156 pi. So this is the lateral area, or the red portion of a can of Coke if this were a soda can. Okay, let's go to the total area. The total area is the lateral area, which we already found to be 156 pi. But now we have to add on the two circular bases. And again, the bases are circles, so we're going to say 2 pi r squared. And the radius of one of those circular bases is 6. Let's make that very clear by putting the center of the circle in and projecting over to the side, saying that, hey, if the diameter is 12, then the radius is 6. So I'm going to put that 6 in for the radius, and this becomes 156 pi plus 36 times 2, which is 72 pi. These two values are like terms, so I can add them together, and 156 plus 72 ends up being 228 pi. So the lateral area was 156 pi, and the total area is 228 pi. Let's take a look at another example. So in example 2, we're asked to find the lateral and total area of a cone with a height of 12 and a diameter of 10. So once again, I think this problem is really screaming for a diagram, so I'm going to go ahead and draw a picture of a cone. Oh, that was a little rough there on the right, but you get the idea. I'm considering doing that over, but I'm going to really hold back. Okay, so let's start with the lateral area, LA. The lateral area of a cone has that formula pi RL. I'm thinking about that MTV show, Total Request Live, TRL. This is pi RL. So this is going to be pi, the radius, and L, of course, is the slant height. I'm not sure if I made that abundantly clear when we went over the formula in the first place. L is the slant height. So this is L, this would be the radius, and this is the height or the altitude. Okay, so in this problem, we never did any specific labeling. They're telling us that the height is 12. So the height is 12 here. The diameter is 10. That would be the diameter of the circular base. And that would mean that the radius is 5. And if we look at that radius and we look at that height, we see that we really have two sides of a right triangle, sides that are 5 and 12. Now, this is a family, which would mean that L, or the slant height, is equal to 13. 5, 12, 13. And let's just make it very clear that L stands for this thing called slant height. So we've got the pi, we've got the radius is 5, and we have the slant height is 13. We multiply the 5 and the 13 together, and we end up getting 65 pi. Now let's go to the total area. The total area is going to be the lateral area plus the base. Well, the lateral area, assuming that we did that right, is 65 pi, and then we're going to add on to it the base, which is a circle, which will be pi r squared. The radius of that circular base is 5. So what we're really going to add together is 65 pi and 25 pi. And the sum of these two numbers is going to be 90. So these are basic little problems, really just plugging numbers into formulas and working off of a diagram that is labeled. Let's go on to the third example.